warned you on Friday. Okay, there's no proofs, but the vocabulary is starting to get, there's starting to be a lot of vocabulary terms we need to be responsible for. And again, I'll say it just like I did on Friday. Might be helpful. Start writing some of them down on the index cards. Okay. I'm going to review real quick what we went over on Friday. Have your packets out. If you need to look back to give me the answer, please look back. All right, before I take any questions on the homework. Friday, we covered 2 sets of lines in a triangle that are concurrent, meaning they all intersect at the same point, called the point of concurrency. So I want to go through right now and fill in my chart. Name me a set of lines that all meet at the same point in a triangle, and then I'll go through the rest. All right, so let's get this going here. Here we go, 11. Name a set of lines that are concurrent in a triangle. Well, one of the 2 that we talked about Friday. The what all meet at the same point in the triangle. We went over 3 sets. We constructed them. We put them on a graph. We used our compass with them. Perpendicular bisectors are concurrent. All 3 perpendicular bisectors intersect at a point called the 3. I know that. I know it's called the point. That's where all 3 lines intersect, but it gave a special name because it was the perpendicular bisectors. Look it up if you need to. This is the only way we're going to get it done. Circumcenter. And there should be one fact you should know about the circumcenter. It is, here we go, 16. Don't have time now. 15. Equidistant. The circumcenter is the same distance away from all 3 vertices. That was the first type of point of concurrency we went over. Then we found another set of lines were concurrent in a triangle, and those lines are called the what? 9. The angle bisectors are all concurrent. They all intersect at a point called the, here we go, 8, incenter. What should I know about the incenter? It is, here we go, 12, equidistant from the sides. And when I say the sides, it's got to be the perpendicular distance from the sides or to the sides. All right, those are all congruent. And the train is not slowing down today. You're going to have another set and a 4th set before you leave today. All right, the train is not slowing down, guys, in an enriched level class. That's why I highly recommend your index card sooner or later. All right, let's go to the homework here. I've already got a couple problems I figure we're going to get asked, so let's go right to them. Here we go, 27 through 30. Have a calculator ready if you couldn't get these over the weekend. Here we go. Here's the diagram. P is the incenter, meaning it was formed by all 3 what intersecting? All right, all 3 what create the incenter? 19. All 3 what for the incenter? Angle bisector. So go back to my diagram. That tells me, everyone, take a look. AD, CF, BE are all what? No. How is the incenter formed? The intersection of all 3 what? Angle bisectors. So what are those 3 lines I just highlighted? Angle bisectors, aren't they? Because this is the what? Incenter. And how's the incenter formed? When all 3 what intersect? Angle bisectors. So if this is an angle bisector, if that's 28.5, guess what that one is? 28.5. If that's 33, guess what the other half is? 33. Because I know it's an incenter, and I know the incenter is formed by the angle bisectors. Okay? No shot, right? No shot if we don't start remembering this stuff. All right, and I'm not getting upset. I'm just trying to show you that this just can't go up. Forget about it. Maybe I'll roll out of bed and know it. All right, somehow it's got to get learned. All right, whether that's coming in with me and working with it or creating some type of index cards. Next up, first question was find PB. Here's PB. Had nothing to do with in-center. Nothing. What type of triangle is PB a part of? And don't you know two sides? How do you find the third side of a right triangle if you already know the other two? I guess we haven't covered that yet. That's for angles, 180 degrees in angles. Come on, killing me today, guys. Thank you, Cameron. How? Pythagorean theorem, anybody? You know two sides of a right triangle? 13 squared plus the missing side squared equals, I'm sorry, not, that's the hypotenuse. So equals 13 squared, 10.9 squared. That's all that was a right triangle. And that's how you ended up with 7.1. So no big deal there. I can't help you there. There's no in-center angle bisector stuff there. Okay, so that ended up being 7.1. And then it went to DE. Well, DE is also part of a what? A right triangle, but there's a problem with this right triangle. I only know what? One side, but baloney. Here you go again. What is point P? It's the what? In center, what's the fact you should know about it? Equidistant from the sides. Tell me 3 segments up here that should be congruent. 3 segments up here. If point P is equidistant from the sides, name me 3 segments up here that should be congruent. Go, Mike, let's go. PF, congruent to? PB, congruent to? PD, yep. So now, do you have a second side to do Pythagorean theorem? What's PD equal to? 7.1, because it's equidistant away from the sides. So now I can go 7.1 squared plus the missing side squared, 14.9 squared. And that will get you to the 13.1. $29, we already answered, DAC. DAC, 33 degrees. Why? Because what's AD? What's AD? Angle bisector, because this was an in-center. And then finally, how do you get DEP? Where's DEP? How about this angle right here? Well, we know those two are equal because what's BE again? That's an angle bisector, right? So any thoughts on how I can find it? And remember, we know these two and we know those two already. Justin, go.
Solve triangle FPE.
Which one?
FPE.
FPE. This one right here.
Yeah.
Doing what with it?
Can't you? Oh, never mind.
Okay. In this entire triangle, how many degrees are there? 180. You already know those, right? You already know this angle. You already know this angle. And then whatever's left over, what do I have to do with it? Divide it by 2, and that's how you get your 28.5. All right. Other than those 4, more we want to go over here. Let's go. More we want to go over. Yep. Go ahead, Karen. 45. Is that the graphing one? Okay, here we go. Got it up already. Now I'm looking for the, I believe it was circumcenter, the question. Circumcenter of that triangle. Okay, here we go. Circumcenter. I'm not putting the chart up again. That's the intersection of all 3. Perpendicular bisectors, okay? A right triangle is very easy for me to do the perpendicular bisectors. Let's go with this side right here. How long is this side here? 10. Where's the perpendicular bisector going to go through? 5, right? There's the perpendicular bisector for AC. Let's do it for side AB, the other leg. How long is AB? 6. Where's the perpendicular bisector going to go through at? 3. Do I need to do the perpendicular bisector for BC? Nope, because I already know where it's going to intersect, right here. And now I just need to figure out what that point is. And it looks like, how many did we go over here on this one? We went over 5. And we went up how many here? 3. 5, 3. We good, Cameron? All right. Other questions? Anything at all? Hopefully we got a little wake-up call there at the beginning that, and these are only 2. And I got to go over another 2 today. Anything else? And not practicing it's not going to help you at all. Whew, yeah, some of you in here. Other questions? Okay, just let me see what you did. Whatever you did here over the weekend. And then get ready for day 2. Just so you know, and I'm not gonna do anything about it. 14 and 15, you probably should have used some type of compass and a straight edge to locate. It was just like our sink, stove, and refrigerator question from Friday. Okay. Keep on moving. Keep your calculators out. Here we go. Okay, more new vocabulary. First one I want to touch upon, median. A median in a triangle. What I'd like you to do right now is right below there, draw yourself a triangle. Read the definition with your group and see if you and your group can come out with a diagram that matches the definition for me. All right, a segment whose endpoints are one endpoint's on the vertex, a vertice of the triangle, and the other is on the midpoint of the opposite side. So see if you can draw in your own median right now with your group. Please make sure you have the correct markings on it as well, because I do see the word midpoint up there. So here we go. Talk it over with your group. See if you guys may differ in your diagrams, but it's still a median. It's got to be a segment. They tell you what the endpoints of the segment are. And make sure you have the proper markings on your diagram. Got one group with it. Not going to do it for free here. Even if you think it's incorrect, talk it over with your group. Some people have it, but I don't know it goes to a midpoint, though, because they don't have any markings on their diagram. Okay, here we go. Here's a good median up here. Again, it is a segment. A segment contains 2 endpoints. Where's one of the endpoints located? At one of the 3 vertices. Where's the other endpoint located? At the midpoint of the opposite side. How do I know that's a midpoint? Got to have these markings there that say it cuts that side in half. All right, so this right here is a median. How many total medians would be in a triangle? Look at that diagram right there. Look where it starts. Look where it ends. How many total medians could I draw in a single triangle? Total medians. Here we go. 12, 3. 1 coming from each vertex. And in a minute, you're going to find out something about those medians, which I think you can predict based on what we did on Friday. Before we get there, though, altitude. Read the definition. See if you can draw me another diagram. This one's a little bit different. and with the correct markings. Right? That doesn't come from a... Couple groups, picking it up. Nice. Okay, let's move here. Another segment, but it's perpendicular to the opposite side. So perpendicular to the opposite side. Does it say anything about going to a midpoint? No. So don't put congruent marks at the bottom because I have no idea if it goes to a midpoint or not. All right, but that is the altitude of a triangle. It's also, just so you know, altitude is another fancy way of saying the height of a triangle. All right, altitude and height go hand in hand. Same question I had for you above. How many altitudes are in a single triangle? How many altitudes could you draw in a single triangle? Well, it's got to come from a vertex, right? How many do I have in a triangle? 3, right? So there's 3 altitudes, and we'll find out something about them in a second. Before we do that, here we go. You and your group, about 2 minutes right now. Tell me what CD is in the diagram. Based on my measurements, tell me what CD is, and the answer may not be median or altitude all the time. All right, so be careful. Here we go, 2 minutes. Get after it with your group. Figure out what CD is. Okay, let's start with letter A here, diagram A. What is CD acting as here? Here we go. 7. No 7 today, even though everyone's here, I think. 7. Oh, Amy. Hey, that's right. Amy's not here. Here we go. 11. That is an altitude. Again, why is it an altitude? Starts at a vertice, perpendicular to the opposite side. That's a good altitude. Okay, here we go. How about part B now? How about part B? Okay, here we go. 16, what do you got? That is a median because AD is congruent to DB, making D what, everybody? Point D is a midpoint. Medians go to midpoints. C was not a median nor an altitude. It was a 2. Yeah, threw a little curveball in there. Angle bisector. All right, I'll do part D with you now. What is CD? Well, take a look. Where does it start from? A vertice, and it's perpendicular to the opposite side. Everyone see that? It starts from vertice C, perpendicular to the opposite side, makes it an altitude. While we're here, let's cover this real quick. If you are given a right triangle, and you guys told me how many altitudes are in a single triangle? 3. 2 out of those 3 on a right triangle. 2 altitudes out of the 3 are going to be the legs. Do you see that? Starts from a vertice and is what to the opposite side? Perpendicular. Starts from a vertice and is what to the opposite side? Okay. So the 2 legs are also the 2 out of the 3 altitudes. And then the other one would come somewhere here, perpendicular to the hypotenuse. All right. Are we okay? Right triangle, 2 legs, altitude. All right. Go ahead. Same thing on the next one. You and your group, about 2 minutes. I throw out a lot of vocab there. Take your time. Okay, let's do this. Name 2 congruent angles. So hopefully you CE was an angle bisector to answer this question. CE was an angle bisector, meaning 2 congruent angles up here would have been. Here we go. Let's figure it out. 13. What do we have? Angle. Angle ACE congruent to, what is it? BCE. Or you could have the reverse as long as C's in the middle. Questions on that one? Moving on, name 2 line segments that are congruent. You could have gotten that from CF being a median. CF's a median, that means F's the midpoint. So that would make what 2 segments congruent? Here we go, 11. AF congruent to FB, perfect. Name 2 segments that are perpendicular. That came from CD being an altitude. So what 2 line segments are perpendicular? 10? CD, perpendicular to AB. Got it? Now use that fact to answer part D. Name 2 right angles up here. Name 2 right angles if you know those lines are perpendicular. 12. CDA, and what was the other one? CDB. Now, I don't know if anybody had CDE or CDF instead of CDB. That's perfectly fine. Anything from you guys up here? Okay, how many medians in a triangle? 3. Let's find them all on the next one. Go ahead, graph that triangle, and we're going to find all 3 medians. Not all together. I'm going to separate you guys into groups of 3 like I did on Friday. So just graph the triangle first, and I'll tell you what your group's responsibility is. Group 1, you guys right over here. You guys have the midpoint of AC. That's all I want you to do. You guys in the middle, you got the tough one, midpoint of BC. And then this group right over here, midpoint of AB. Let's pick that up, Justin. Now group 2 has the tough one. There's that formula again. Okay, let's roll. Midpoint of AC. Here we go. Midpoint of AC, group 1. What do you got for me? 5, 5 is correct. Make sure you call that point E, everyone, all right? Make sure everyone's getting this down, not just yours. Make sure we get all the midpoints down. Group 2, what'd you find the midpoint of BC? 8, 4, we're going to call that point F. 8, 4. And finally, group 3, midpoint of AB? 5, 3, and we're going to call that point G. So everyone take a minute right now, copy down the midpoints, and graph them for me. Graph them for me. Point EFG. Once you graph the points, draw in their medians now. Vertice to opposite midpoint. Vertice to opposite midpoint. As straight as you can. I don't have time for people to come up and grab straight edges. So as straight as you can. And I'm hoping everyone is starting to find out that those three medians are concurrent. They all intersect at the same point. As long as they're graphed correctly and the medians are drawn in correctly. Is that what we're finding out here? Okay, can you put a point at that point of concurrency now? All right, place a point at the point of concurrency. Can we make a decision as a class what letter we want to represent here? Obviously one that hasn't been used. You want to go Y? Okay. Call the point of concurrency point Y. All right, so if I go back to where we started today, we just found out what? What else are also concurrent? Perpendicular bisectors, angle bisectors, and now you just found out the what? Medians, yep, are concurrent at a place now, and it's already there, so I'm not giving anything away. But that point of concurrency we just labeled as point Y is known as the, anybody want to pronounce that bad boy? Centroid, yes, centroid is the point of concurrency. For the medians. For the medians. What's so special about it? Here we go. What's so special about the centroid? Ready? I'll tell you it and then we'll write it down. It breaks every median up into a ratio of 2 to 1. Right? And I know that may not make sense right now, but breaks every median up in a ratio of 2 to 1. So here's what I need from somebody. Somebody just give me a name of a median up here. Median, name it by its letters. Median, AF. Thank you, Nick. Median AF. AF is broken up into what? AY and YF, FY. All right. The centroid breaks it up so that AY is twice the length of YF. So this portion from the vertice to the centroid is double the length of the other portion. All right, it's twice the length of the other side. Name me another median up here. Go ahead, name me another median. CG, you got it. And it's broken up into what? CY and YG. What's the relationship? They're not equal, but CY is twice the length of YG. And can you guys come up with the other one for the other median? We have not spoken about AF yet. No, sorry, we have. We haven't spoken about EB yet. So what do you know about those two segments now on EB? BY is equal to what? 2 times EY or YE. Yep. And try to remember, the bigger part is always the part from the vertice to the centroid. That's always the bigger part. All right, let's put it to use now. Here we go. M's the centroid. Got it. M is the centroid. WM is 16. So that part right there is 16. Find WX. Everyone look where WX is. WX is the length of the entire median, right? Okay, so before I find WX, can you find me XM so I can add it to that 16? Remember the relationship, 2 to 1. 2 to 1. The bigger piece is always vertice to centroid. So how long is XM up here then? Here you go, 17. How long is XM? 8. Half of 16. Meaning, I'm not going to ask anybody here, but WX will be 24. 16 plus 8. And then number 3 is kind of tough to do. Consider, and I said if blank equals 12, right? That's going to be kind of hard to do. It's Y, what I did not give you, YM is 12. YM is 12. Find YO and MO. Okay, so I gave you YM is 12. Okay, let's be careful here. What's MO then? Let's go MO first before you give me the length of the entire median. MO, what do you got for me for MO? Here we go, 13. Okay, remember, where's the bigger part? You can't just cut everything in half. Bigger part is from vertice to, this is the bigger part. If you give me 6, it's not the bigger part. This is the 1 part. Now I'm looking for the 2 part. So it would be double that, 24. Everyone see that one? You just can't cut everything in half. You got to say, am I looking for the bigger part or am I looking for the smaller part? So there's 24 for MO, and YO is going to be 36. Boom. All right. Let's take away the numbers now. Let's do some expressions. First question I have for you, though, don't start anything, because I do not see the word centroid in number 4. I don't see the word centroid. But how is G formed? Point G is formed by the intersection of what? 3 what? Medians. 3 medians. So where 3 medians intersect is called the centroid. It may not say the word there, but hey, I know that the medians all intersect at the centroid. All right, what do I have? BG 2x plus 10. And I have GE as 3x minus 1. All right, well, we know for darn sure those two aren't equal to each other. No chance are they equal. So I'm going to ask somebody to adjust that equation so they are. Remember, G is the midpoint, breaks it up in a ratio of 2 to 1. How can I adjust this equation so it's correct? Because right now it is not. Here we go, 12. I could do that, or I could multiply this by what if you needed to? 0.5 or a half, that's fine. All right, so we'll multiply it by 2. That's what Emma gave me, so I'll go with it. So go ahead, let's find the value of x, because that's not the final answer. We get an x equals 3 out. Solve the problem now. Find BE. I'll call on somebody here in about 30 seconds. Find the length of BE, which is the entire median. BE, length of BE, what do we got? 4, what do we have? 24, yep, you should have ended up with 16 plus 8 for a length of 24. Perfect. Questions right there. All right, so let me go back to today right now. So we know circumcenter, incenter, we just found out what? Where all 3 medians intersect? Centroid. The fact's a little too long to write down about they breaking the median up into 2 to 1, but we still have one more. What was the other vocabulary term we went over today? Medians and altitudes. Yes, there's the 4th and final set of concurrent lines. And I don't really have anything fancy here for you other than telling you where they intersect. And that's called the, anybody want to try to pronounce it? Orthocenter. Yep, that's the point of concurrency. For the altitudes. And I always save this one for last because, unfortunately, there's not a theorem or a cool fact about it like the other 3. Okay, there's no really fact that it's, breaks it up into 2 to 1, equidistant from the sides, from the vertices. There's no real good theorem about it. But what I still need you to do is know where it is. All right, depending on the type of triangle. First type of triangle, it could be an acute triangle. Meaning what again? Acute? From last unit. All angles, all three angles less than 90. Okay. So if you take my acute triangle up here, what's an altitude again? Where's an altitude start? From a vertex, and it's what to the opposite side? Perpendicular, right? So if I just freehand this in here, 3 perpendicular lines in an acute triangle, here's the orthocenter. And what I mean by the location is, where is it? It's always located inside the triangle. Okay, well, how can it be located outside? Oh, we'll get to that in a second. Okay, so anytime you have an acute triangle, the orthocenter will always be located inside the triangle. Anybody know what type of triangle I have next? Oh, okay. And I'm going to break the news to you. It won't be located inside. Do you guys remember when I went over this with altitudes on problem D, I believe? Where are 2 of the altitudes on a right triangle? The legs, right? So here's an altitude. Here's an altitude. Guys, where do they intersect? Ready? Where do they intersect? Boom, right here. Don't they intersect right there? And if I found the third altitude, still going to be right there. So how can you tell me where the orthocenter would be in a right triangle? Because it's right here. It's not inside. It's not outside. I like on. Yes. On the triangle. And then if you want in parentheses, where the 2 legs meet. Okay, where the 2 legs meet. Do you see that? Again, the 2 out of the 3 altitudes in a right triangle are the legs. Where the legs meet, where the right angles form. So there's your orthocenter there. And then anybody know what this last type of triangle? Yeah, obtuse. One last time, what's the definition of an altitude? Starts from a vertex and is what? Perpendicular, right? Don't draw this in because it's incorrect. Does that look perpendicular? Does that look perpendicular? No. Where am I going to be able to draw a line that's going to be perpendicular? Straight down here, right? But is that inside the triangle? No. That's outside. So if I drew another altitude in, guess where they're going to intersect? Inside, outside, on the triangle? Outside. So when you have an obtuse triangle, the orthocenter is going to be located somewhere outside, because you cannot draw a perpendicular line down. It's got to be on the outside of the triangle. All right, and then lastly, flip it over. Don't do it now, but first thing tomorrow in class, that's what I'm going to expect you to fill out. All right, which is the chart I've been referring to all day today. All right, don't do it now. Do it before. There is no assignment sheet. It's right here at the bottom. Okay, I didn't figure the assignment sheet was necessary for 2 days of class. All right, so you guys know what the assignment is. It's at the bottom.